Alright, today's notes are going to be over composite and inverse functions. Before I start anything, kids were confused about this. If I told you f of 2, let me give you a function. If I say f of x equals x squared plus 3. If I gave you f of x equals x squared plus 3, and then I asked for f of 2, what does that mean? Right, everywhere you see an x, we're going to take a substitute. Take out the x, and we're going to put it instead of 2. So then instead, I would say, okay, where I see an x, I'm going to write 2 squared plus 3. So 4 plus 3 is 7. So f of 2 is 7. When you plug in 2 into this function, what do you get out? 7. Remember, it's like 3rd grade. I think my son does functions, right? Put the little number in the function box, plug it in, and whatever you get out, that's all it is. Okay? That's what today is on the most higher level. Okay. So if we start, then, I'm going to talk to you about a composition of functions. So, composite. It looks like the word fog, but that G is supposed to, I'm sorry, that O is really tiny. And it's also written like this. Those are the same things with different notation. It's kind of like calling you by your first name or your first and last. Same thing, but a different way to represent it. It's actually not called fog, okay? It's actually called f of g of x. So the best way to think about it is that little bitty o. Think about it as the word of. F of g of x. You can write yourself a note. The way it's read is f of g of x. That's how you read it, if you didn't know that. What I'm going to do is I'm going to give you some functions. Remember the other day I told you we'll call one name Ben and one line we might call Sue, right? Well, that's like same thing. I'm going to name one line f of x and I'm going to name another line g of x. I'm going to mess with the two functions. So we're going to start off with, if I given f of x is going to represent x plus 2, and g of x is going to represent 3x minus 1. Those are the two that we have so far. I'm going to manipulate it a lot of different ways. By starting, I'm going to ask you for f of g of x. Read that to yourself once or twice to get the hang of it. F of g of x. It's kind of like this is in the middle, right? F of g of x. Now, since my smart board is working today, hopefully, I had trouble with it all day long. Okay, got a basketball game, right? And we're gonna, when the horn goes off in a basketball game, usually it means they're gonna do what? So maybe in the basketball game. What? In the quarter, yeah, that's one reason. What else? Substitutions, right? They'll make the buzzer and then they'll trade. Okay, that's what we're gonna do here. Okay, this is saying you're gonna take one player and substitute in for another player. That's a way to kind of think about it visually. So what you're gonna do in this problem, and you always start this way, you're gonna take player G and plug it in for F. What are we calling player G over here right now? We're calling player G what? Yeah, this is what we're calling player G, 3x minus 1. We're going to take the player, 3x minus 1, player G, and we're going to make a substitution. We're going to come over to which function? We're going to come over to F, okay, all the way over, and we're going to kick out X. We don't want him in anymore. He's going to go sit on the bench, right, out, right? And we're going to put in a new player. What player are we going to put in? The whole thing, 3x minus 1. Okay? So that's how you do that. Let me erase this and show you. So when you're asked to find this, this is saying take G and plug it in for F. Or in other words, in this particular problem, we're going to take this function and plug it in for here, kick X out. So when you write it, instead of X inside, we substituted this whole entire 3x minus 1. That's that guy's name, right? But what about my 2? Is there still players on the team? They stay there, don't they? Well, the 2's going to stay there. So drop the 2 down. We're going to keep the 2. And now you can evaluate it. You're going to put these 2 together so you end up with 3x plus 1 as your answer. Let's go to B. We're going to go the other way. G of f of x. It's backwards, right? You're going to go the other direction. I'm going to erase this, which is what I did with pencil. Okay, and in this problem, you go the opposite direction, right? You're going to take player F, and you're going to substitute F into the game. Start in the middle, right? You're going to take F and substitute it for G. So in other words, you're going to take this player, which is named X plus 2. Okay, watch me physically so you understand this. We're taking player F right here, X plus 2. And we're going to come over to G, and who are we going to kick out? Just the X. We're going to kick X out of the game, and who are we going to put instead? Somebody named X plus 2, right? So now then we've got 3, and instead of X, we're going to put this new player, and his name is X plus 2. What about my minus 1? Is he still out on the court? Yeah, so leave him on the court. Now, order of operations just says to solve this. So distribute your 3, so you'll have 3x, go to the 2, plus 6, minus 1. Now, put these together, 3x plus 5, and that's your answer. Does that make sense? It's kind of like substituting. Take whoever it is and put him in the game. Let's go to the next one. For C, this time we're going to do f of g of 2. Looks a little bit different. We're still using these same 2 functions, okay? Basically, you'll get 2 functions, you'll use them for a while. You'll get 2 more, you'll use them for a while. This problem's done a tiny bit different. When you have a number buried inside, what's the number that's buried inside our function? 2. Okay? Remember the problem I showed you earlier? You found f of 2 for me? The same kind of thing's going to happen now. The first step, okay, you can write this down if you want. You're going to find g of 2 first. This is kind of like a 2-step problem. Get the value. Then plug into f of x. Okay. When you plug in a number, you usually get a number out. So let's find g of 2 first. Here's my function g. I'm going to find g of 2. That means I'm going to take 2, and everywhere I see an x, I'm going to kick x out of the game, and who are we going to put in its place? Something called 2. Okay? So in this case, it only happens once. So 3 times 2. That does not mean 32. 3 times 2 minus 1. What's 6 minus 1? 5. So when we plug 2 into the function, what did we get out? 2 gave us 5. What's it say to do? Find g of 2 first, then plug it into f of x. So this value actually is how much, guys? This value is, here's 1 step ahead, it's fine. You're going to take 5 and plug it in now. This is 5, so now I'm asking, well, okay, Put 5 in. Go up and look. This is where you got 7. Plug 5 into the f function. So I'm going to have 5 plus 2 instead of x plus 2. What is 5 plus 2? 7. So your function then is 7. Okay. One big thing. Listen. When you write an answer, when there's a problem, notice on A, we did g of x, and we wrote our answer, we just wrote 3x plus 1. Okay. When you put a number inside, so for example, g of 2, when you write your final answer, it'll read f of 5 gave me 7. Do you see that? Don't write just 7 when you plug in a number. Tell me how you got the number. The more we do those, the better you'll get it. Here's D. This time I want g of f of negative 3. Remember the secret. I'm going to put it down so you can see. Go back to the top and you're going to find this value first. Plug in negative 3 in for f. Where's that at? Where's that? It's right here. You're going to take negative 3. I want to know what is f of negative 3. We already talked about that. That means take negative 3. Everywhere you see an x, cross it out, and what are you going to put in its place? A negative 3, right? So negative 3 plus 2 is negative 1. F of negative 3 then is negative 1. What did I do with that negative 1 now? Do I remember? If you're still struggling with it, okay, remember this goes away. The value of f of negative 3 is negative 1. So now what I'm asking for is what's g of negative 1? Correct? Okay, so where's g of x? It's up here. I'm going to plug in negative 1. Everywhere I see an x, I'm going to kick them out of the game. And what am I going to put in its place? A negative 1. So 3 times negative 1 minus 1. Order box says to do this. So when you plugged in negative 1, we got out negative 4. When you plug in just a number, your answer has to be written like that. I'll move it up so you can see. G of negative 1 equals negative 4. Okay? Now I'm going to give you 2 new functions. I'm going to tell you f of x is x over 5, and g of x equals x minus 2. Those are your 2 new functions. Your first question is A, g of f of x Okay, let me explain it again. You ready? It's like a substitution. We're going to make a substitution. Correct? Sorry. We're going to take player F and put it in where? Where are we going to take him? We always start in the middle. Take F and put him in for G. Correct? What are we calling player F right now? We're calling him x minus 5. Agree? We're going to come over to G and kick out this guy and put in x over 5. So on your paper, you would write, I'm going to put it in for here, so I'm going to write x over 5 minus 2. Correct? If you get a common denominator, if you have 5 and 1, the common denominator is 10. Okay, which would leave this as 2x minus 5. Then you have to reduce it all. So if you see it written this way, that's fine, but I'll also take x over 5 minus 2. Okay, either way. Oh, Oh, I made a mistake there. What's my common denominator, guys? I'm sorry. I just went too fast. I looked at the wrong two numbers. Let me catch up with there we go. Common denominator is 5. There we go. So that matches. There's my x. There's my 10. Is that better? Either answer is fine. Correct. Like either. Okay, go to B. I gave you g of f. Now we're going to go the other way. Okay, we're going to plug g in for f. In other words, we're going to take x minus 2, this player right here, and who are we going to kick out of the game? Just the numerator, right? We're going to kick out that top x. So we're going to come up here, we're going to kick out the top x. So what's the new numerator going to be? X minus 2. What's the denominator going to be? 5. Good, you got it. So the numerator then is going to be x minus 2, and the denominator is going to be what? 5. Not x minus 2. Okay. The next one. What if I ask you for f of x? It's kind of weird, isn't it? I'm going to move it up so that I can have room. Okay, let's talk about it for a second. You agree that f of x is x over 5, right? And I want to plug it into itself. Okay, well, I'll give you a little hint. Just write it down twice. Because I want to take f and plug it into f. So I wrote down 2 f's to help us out. Okay? And then just do what we talked about. We're going to take f, which is right here. And who are we going to kick out, guys? Just the numerator. So in the numerator now, we have x over 5. And what's in the denominator? 5. Has it been a long time since you've done division of fractions? Been a while, right? All summer maybe even? Okay, so here's a little reminder. Look, come over here for a little think session. Let me remind you how to do fractions. What if I told you 2/3 times 1/2? Do you remember how to multiply fractions? Tops and what? Bottoms. You just multiply. 2 times 1 is 2. 3 times 2 is 6. And then you would reduce. So when you multiply fractions, you multiply tops and bottoms. But when you divide fractions, what if I said 2/3 divided by 1/2? Do y'all remember what you have to do? Good job. You change division to times and you flip the second number. Do you remember? And now it's just a multiplication problem. Multiply straight across. 4 over 3. Okay, so if you remember that, then let's do this problem. I've got a fraction on top, and I'm going to make a fraction on bottom. What do I do to this big old division bar? Turn it into multiplication. Excellent. I'm going to change this to multiplication, and I'm going to flip this to make it 1/5. It was 5 over 1. I made it 1 over 5. What was my little trick? Tops and bottoms when you multiply. So x times 1 is x, and 5 times 5 is 25. Make sense? The multiplying fractions will help you. We're going to need it. Go to the next one. What if I told you that we're going to be given f of x equals 3/5 x plus 1. And then I'm going to tell you g of x equals 1 minus 3x. So those are your 2 new functions. here's your first problem. F of g of x. This problem is the same that we've been doing before. It's just now I'm going to throw in some fractions. Okay? Exactly the same. So if you have the hang of it, then you're good. Take player G and plug him in for F. In other words, you're going to take this whole entire player, come over here, and kick out X. Right? G into F. So if we do that, we end up with 3/5 times all of x, which they call 1 minus 3x, don't they? We're putting this whole entire player in for x, the whole thing. But don't forget to do what? Is this guy still playing? Yeah, drop him down. Now try some distribution. How good are you at distributing the fractions? Give it a shot. Okay, 3/5 times 1 is 3/5. Come over here and do a little trick I taught you. 3/5 times 3. Okay, 3/5 times 3 over 1. We do tops and bottoms, right? Numerators and denominators. So that gives me 9 over what? 5. And there's an x there, and it's minus. So minus 9/5 x. Drop down your plus 1. I know it's been a while, but I need to put the 3/5 and the 1 together because they don't have an x. How can I rewrite 1 so that I can put it with 3/5? Oh, it's something over 5 is the same. I heard it. 5 over 5. Isn't that the same as 1? And now then 3/5 and 5/5 makes 8/5. So negative 9/5 x plus 8/5. Nice and messy. Wouldn't want it to be pretty, right? Okay, let's go to B. Your other problem goes the other direction. G of f of x. Go the other way. I'll give you a second to at least try to set it up. If you can set it up, you're in step 1. Then you just got to practice your fractions. Set it up. Try. Take this and kick out just the x. So you would end up writing 1 minus 3 times the whole thing. 3/5 x plus 1. Raise your hand if you at least got that line right. Okay, you're 50% of the way there. Now let's just practice our fractions. Okay, here's a common mistake kids make. They put the 1 and the 3 together and make negative 2. But doesn't order of operations say you have to distribute first? Okay, don't make that mistake. So let's distribute. I'm going to drop down this 1, and that is actually a negative 3. Negative 3 times 3/5. Put it over 1 if that helps you. Numerators and denominators make negative 9/5 x. We have 1 minus 9/5 x. Then a negative 3 times positive 1 is negative 3. Put together the two that match. So you have a negative 9/5 x minus 2. Okay, that is composite functions. We're going to switch now to do inverse functions. Inverse relations. Okay. That's where x and y values are switched. So for example, if you had 3, 4, you would switch it to 4, 3. An inverse relation is where the x and y values are switched. So 3, 4 becomes 4, 3. That's an inverse relation. Inverse notation. You know how sometimes we call a line f of x and then we rename it as g of x? If I don't rename it, you would think it's the same line. That's this. If you switch the x's and y's, you have to rename it. So instead of just saying f of x, they rename it, and it looks kind of strange. They put this little -1 in, okay? So it'll look like this. Or sometimes they just say y -1. Either way is fine. Okay, that little -1 means inverse. So if you find the inverse of a function, you'll know it's the inverse because it's got that little -1 there. Okay, let's try one. I'm going to find the inverse. Okay, the first step, flip x and y for me. Or your mother. Yes. Okay. Okay, so the first step is to flip x and y's. So let's do that first. So I'm going to make this x, and I'm going to make the x y. You see what I just did? It's very easy. Do you get what I'm trying to say? Now I'm going to solve for y. So we're going to solve for y. So move the 2 over. And then what am I going to have to do? Divide by the what? The 7. But we can't call it y equals anymore. Remember, what notation do we use for that little crazy -1? There you go. This is called the inverse. And let me show you something cool. Watch. Look at my original problem up here. Right here, this. I had x multiplied by 7 and added 2. Come down here. I subtracted 2 and divided by 7. Do y'all see that it's kind of the undo of everything? Instead of adding 2 and multiplying by 7, we have to subtract 2 and divide by 7. Now, don't try to do that on your own. You have to work through it because order of operations makes a difference. Okay? This one's just very basic. So let's try another one. What if I told you y equals x plus 8 over 2? What's your first step in finding an inverse? Switch to what? Excellent. Good, y'all are listening. Switch the x and y. What's my second step? Solve for what? Solve for y. So solve for y, you want to solve for y. Multiply both sides by 2, so you'll have 2x equals y plus 8. Subtract 8, so 2x minus 8 equals your y. So the box in yellow was my function. What's the box in black called? It's what? It's inverse. Okay? Good time for one more. How about y equals the square root of x plus 5? Find its inverse. What's your first step in finding the inverse? Switch x and y, that's step 1. Step 2 is solving for y now. So move the 5 over. How do you get rid of that square root? What do you do to both sides? Good, square both sides. So now we call it, don't forget your -1, so I know it's the inverse. And then you can just leave it like that if you want. Out of curiosity, is this answer x squared plus 25? No. In order to square that, you write it 2 times and FOIL it. That's actually the answer to that. But leaving it in that form is fine. Okay, we're done for today.